All right, welcome back. All right, so let's continue. In the previous video, we just found the sine value, cos value, and the tan value for our boundary angles, right? Which is 0, 90, 180, 270, and 360, right? Which is 0, pi over 2, pi, 3 pi over 2, 2 pi radian. Right, now what we're going to do next is we can find more exact values, right? More exact values for more angles, all right? But to do that, we need to draw two very special triangles first. Let's come down to here. Okay, so let's draw our first triangle, which will be an isosceles triangle. All right, isosceles triangle with 1 and 1. I know it doesn't really look like 1. Let's make it look like 1, okay? I know it's not big. It's a bit ridiculous. It doesn't look like 1. I'm trying to draw to scale. To scale. All right. So like that. Artistic. All right. So it's 1, 1 here, and this is right angle triangle. And according to Pythagoras' theorem, we know that c squared is equal to 1 squared plus 1 squared. So c squared is equal to a squared plus b squared, right? So we know that is root 2 over here. All right, root 2. Now, in isosceles triangle, so this two side is the same. In isosceles triangle, we know the angle here and here is the same, all right, for any isosceles triangle, okay? So, and we also know that there are 180 degrees or pi radian, right, in any triangle. All right, we know that. So given that this is 90 already, this must be 45 and 45. And they add up to be 90, and 90 plus 90 is 180, and that satisfies the rules, right? So that's 45 degrees. All right, but we also have to convert that to radian as well, you know, because mathematician likes to work with radian when it comes to angles and stuff. So now we know pi is 180, right? Now 90 is half of 180, which is pi on 2. And 45 is half of 90, so which is half of pi over 2, which is half of pi over 2. So half of pi over 2 is literally half of a half is literally a quarter. All right, so 45 is the same as pi over 4. Yeah, and using our sine, cosine, using our trigonometry, we can find out the values for 45 angles here. So let's go. So we got 0 slash, not 0, we got 45 degree here slash pi over 4, right? It's the same thing. So we got okay, let's use the color coding system before. I'll use the black to draw the angles. So 45 or degree or pi over 4 radian. So if we're using sine, now sine is opposite over hypotenuse, right? So in this case, since both angle is 45, right, it doesn't really matter which one is which angle you use. And since both sides is 1, it literally doesn't really matter which side which angle you use. So sine is equal to opposite over hypotenuse. So let's just choose this one. So sine is equal to opposite over hypotenuse, right? So that's equal to 1 over root 2. Right? 1 over root 2. Okay? So cos will be the same thing. So cos 45 will give you 1 over root 2 as well. Yeah? Because we use this one and these ones. Yeah? And the last bit, last but not least, 10. Now, I know that. I don't have to look at the diagram. In fact, I know that. Sorry, okay, let's just look at the diagram if you want. Now, the diagram says that 10 is opposite over adjacent. Right? So it's opposite over adjacent. Correct? So it's 1 over 1. So I know it's 1. But we can also look at the value here. We know that tan theta is equal to sine theta over cosine theta, right? And now sine theta is this, and cosine theta is sine theta is 1 over root 2, and cosine theta is 1 over root 2. So sine theta divided by cosine theta is 1 over root 2 divided by 1 over root 2. We literally divide the same thing by itself. Of course, they will give you 1, right? 1. Yeah. All right, so this particular triangle, this particular isosceles triangle, will help us to find out the exact values of 45 angles. Okay, so the next, and that's it. I mean, unfortunately, this is what this triangle gives us. All right, but we can draw another one. But in this case, it wouldn't be an isosceles triangle anymore. So it would be something a bit more irregular. So still a right angle triangle here. So this time, this side's length is 1. This side's length is root 3. And that side is 1 square plus root 3 square. 1 square is 1. Root 3 square is 3. 1 plus 3 is 4. And square root of 4 is 2. So this side will give you 2. The hypotenuse will be 2. Right? So this is another special triangle because the angle here is 60. And the angle on the other one will be, yeah, because all of them have to add up to be 180. So this is 90 over here. So this one must be 30. Right? And in terms of radian, 180 is pi, right? 180 divided by 3 gives you 60. So it must be pi over 3. And the other one is half of 60, right? 30 is half of 60. So it's just half of 1/3. They give you 1/6, right? So it's just pi over 6. So with this triangle, it allowed us to get some exact values for 2 more angles, which is 30 and 60, right? So let's just write it down. So 30 degree is pi over 6, and 60 degree is pi over 3. Right, let's go with 30 degree first. Looking at the 30 degree angle, sine is equal to opposite over hypotenuse. So we get 1 over 2. Right? The other bit, the cosine 30 is adjacent over hypotenuse, which would be root 3 over 2. Cool. Now tan is just opposite over adjacent. So it would be 1 over root 3. Right? So far so good. All right, next one, last one. 60 here. So with respect to the 60 angle, to the angle of 60 degrees, Sine is opposite, right? Sine is opposite over hypotenuse, which give you root 3 over 2. Correct? And cosine 60 is adjacent over hypotenuse. And that would be 1 over 2. And last one, 10. 60 will give you opposite. 60 will give you opposite over adjacent. Yeah, so it's root 3 over 1, which is just root 3. But let's just put it this way, root 3 over 1. And now that's just root 3. All right, so we got some exact value for 3 extra angles other than our boundary angles. We got exact value for 30 degrees, 60 degree, and 45 degree. Yeah. All right. So before we go on though, just want to say a couple of things about some of the numbers here. So when we got a root 2 or root value at the bottom of the fraction, which is our denominator. Now the mathematicians don't like that because we know root 2. Root 2 is an irrational number. So what that means is if we're trying to calculate root 2, it will go on forever. All right, it never ends, just like pi, just like Euler's number. It just keep going on forever. And when you divide it by something that keep going on forever, would you ever be able to divide it? Right? So that's why mathematicians don't like that idea of having a root 2 or any irrational number at the bottom. So to counter that, what they did is they want to times it by root 2 over root 2. Now, root 2 over root 2 is 1, right? So 1 over root 2 times 1 doesn't change its value, but rather it changes the expression of the number. So if you do that, will give us 1 times root 2 is root 2, and root 2 times root 2 is 2. Okay? And now, from an irrational denominator, we change back to a rational denominator. So it's something definite, it's just 2. So something divided by 2 is more definite. All right? So that's why they would prefer this particular expression instead of 1 over root 2. Right? I'm not saying 1 over root 2 is wrong, but it's just the general convention that people don't do that. People don't write that down. Okay? So we can change that. Yeah. To root 2 over 2. Same as the bottom one. Yeah, same as for our cos 45. So it would be root 2 over 2. And the last one we need to change would be our sine, would be our tan 30, yeah? And that would be root 3 over 3. That's it, right? Looks good. Everything looks good. Now, so these are all the exact value that we can, including the one that we found for the boundary angle, that most of the year 11 and year 12 would need for unit circle. So I'm not saying, look, this video is called going beyond the expected. So I'm not saying that this is all that is out there. Of course, there will be more. So hopefully you can reach out to them. But for year 11 and year 12, this is what you need. This is what you need to remember, and this is what you need to be able to do to find the exact value for all these angles. All right. So the first important thing is we have to know our boundary angle. Right, we have to know our x coordinate and y coordinate of a unit circle, which is easy, right? You just draw a circle, right? You just draw the circle like here, and we go boop, 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 boop. And we know those points. We know the radius of the circle is 1, so this from here to here is 1, from here to here is 1, from here to here is -1, and from here to here is -1. So we know that. All right, so that's not a problem. And the next thing we have to remember to do is to draw our special triangle. Remember how to draw them. One of them is the isosceles triangle, which is both of the short side is the same, and the hypotenuse will be √2. And then the other one will be a little bit more. There's no order to remember, but I always goes 1, 2, and √3, like that. And I know the 60 degree, the bigger angles on the bottom bit, and the 30 degrees on the top bit. So that's how I remember it. All right. Now another thing is, most of the high school teacher don't actually say this, but what I want you to, but since this video is going beyond the expected, so I want you to know, I want to share this with you. So we see this 1 here, 1 √2 and 1 √3 2. Now, just like unit circle, these two triangle has been simplified to its basic form. So we can call this unit triangle, right? Because that's the most basic form, basic. And just like the unit circle, right? You can have a radius of 1 or radius of 100 times of 1. All these value 1 √2, 1 2 √3, they are all just ratio or proportioned. All right, so you can literally multiply them by the same thing, and this will stay, and this triangle will stay true, and everything will stay true. Right, you can times everything by the same scale, and it will remain true. So just keep that in mind. The 1 √2 and the 1 2 √3 in these two unit triangle, they are just ratioed. All right, ratio for you to so you can add a particular factors on it. You can be a 2 or 3 or 4 or 100 or 1,000. It still doesn't change its characteristic. All right, you will still have a 45 angle on the isosceles triangle, and the 60 and 30 angles on the second special unit triangle, as long as the ratio on the free side is 1 √2 or 1 2 √3. Okay, just keep that in mind. And I think that's all about the exact value that we can get from a unit circle. All right. And of course, this is not the end yet. The next thing we're going to talk about is the symmetrical feature of a circle. Well, we know that the circle is symmetric, right? The left half is equal to the right half, the top half is equal to the bottom half. But now we're going to look into that particular characteristic of the circle, and we're going to discover 4 quadrants. All right, normally that's what the teacher called them, 4 quadrants of the circle. The first quadrant, second quadrant, third quadrant, and fourth quadrant. And we can, by identifying the quadrant and identifying where the angle we're trying to find, and where the particular angle is in any so which quadrant that particular angle we're trying to find is in, we can find some information about our answers. All right, but I'll leave that to the next video. Okay, so that's it for now. We'll see you next time.